So research methods, the data section of research methods for year 1 psychology, so this is your ASL. So what do we need to know? We need to know about quantitative and qualitative data, primary and secondary data, measures of central tendencies, measures of dispersion, how we can present and display data, distributions, levels of measurement, and the sign test. So quantitative and qualitative data. Quantitative data concerns facts about a social phenomenon. Generally, is collected through measuring things. It tends to be numerical data, so it's data in number, and data is reported through statistical analysis. So, strengths of it is easier to see patterns and it's easier to summarise and present the data. Statistical analysis can be carried out through inferential tests, so we can say whether we have a significant result or not. However, because it is data in numbers, it doesn't provide as much detail as qualitative data, so a lot of information is lost. Qualitative data is generally in words, so it's rich and detailed. It is analysed by themes from the descriptions, and it's reported in the language of the participant. So for example, thematic analysis within case studies and content analysis. So the researcher becomes familiar with the data and looks for themes within the data, reviews the themes, refines them until they've generated a report based on what they have found. So the strength of it is that it preserves the detail. It's really in-depth, detailed data that has been collected. However, it can be difficult to decide which categories to use and whether the statement fits into a particular category. It's difficult to decide what to leave out or what to summarise and what best fits. Also, it can be difficult for you to carry out a statistical test on the data because it isn't numerical. So primary data is information that is collected during a researcher's direct observations of the participants. So the test results, answers to the questionnaire, observations, and generally they have more control on the data because it's the original data from the experiment. It is unbiased as the researcher has collected it themselves. However, it can be time consuming to collect the data and analyse it. Secondary data is information collected from other studies. This data can be used to check the validity of studies or used to provide evidence to support or discredit a new theory. It saves time and resources as someone has already collected the data. It enhances the breadth of data that is available. However, as the researcher did not collect the data, the researcher doesn't have control over what is contained within the data set. So you should notice that the strength of one is the weakness of the other, and vice versa. So that should reduce the amount of information that you need to remember. Meta-analysis is where you analyse the results from a large number of studies and you come to a general conclusion. So think back to Van Isendorn and Kroonenberg's study on cross-cultural variations of attachment. It's a good way of bringing together data with the general aim of the scientific process, and by doing this it reduces the problems with sample size and participant bias and individual differences. However, one problem of doing meta-analysis is there's a significant amount of conflicting results out there which can make completing a meta-analysis tricky. Also, there's an issue with publication bias within meta-analysis. So I mentioned this when we looked at the peer review. Generally, research that has been published tends to show a certain result. Therefore, meta-analysis only has access to this data. It only has access to studies that have been published and those data sets within published research. Measures of central tendency. So this is the posh way of saying the mean, mode and median. So the mean is the arithmetic average. So this is calculated by adding all the numbers within the data set and dividing by the total numbers that you have. So strengths of it is that it uses all the data and there is a centre point of actual data within the values. However, it's not always an actual score. Sometimes you end up with a number that doesn't make sense. So 2.4 children. It's impossible to have 2.4 children, so it's not a number that is useful. And it's easily skewed by one anomalous number. The median is the middle score or value found in the data when it's turned into an ordered list. It's unaffected by extreme scores and it's relatively quick and easy to calculate. However, there may not be an actual score if there's an even number of scores, and it's not good for small data sets where there's a large difference within your data. The mode is the most common or frequent score, so it's not distorted by extreme values, it's always an actual score. However, it doesn't use all the data, and sometimes the data doesn't have a mode, or it has more than one mode. Measures of dispersion. This is where you analyse how far the scores are from the average participant response, so the spread of the results. The range is the difference between the highest and the lowest scores within a data set, so it's calculated by subtracting the lowest score from the highest score. So advantages, it's easy to calculate, it takes into account extreme values. However, it ignores most of the data, it doesn't reflect the true distribution around the mean, and it's easily distorted by an extreme value or score. Standard deviation is the result of a calculation which measures how much each individual scores deviates or is spread from the mean, and presents the finding as a single number. So it tells us how much data spread there is from the mean. A large standard deviation tells us there's a lot of variation, so the participants were responding very differently, whereas a small standard deviation tells us there is a small variation, so that the participants were responding in a very similar way. So this is precise as all values are taken into account. Its detailed conclusions can be made, however it's not that easy to calculate, which may mean it is time consuming. So how can we present and display data? So we can use tables. So generally they show either the measures of dispersion or measures of central tendency. We can use a bar chart, so when data falls into categories. The x-axis has the categories along the bottom, and the y-axis has the frequency, so the amount of scores. The height of the bars represents the frequency, so the number of the times the category was recorded. The columns are of equal width, and within AQA psychology the bars should not touch one another because it's discrete data. Histograms are used when the results can be put in a continuous order. The x-axis shows all the possible scores in order, and the y-axis shows how many participants got that score. The column height shows the frequency, and all columns are of equal width, and there's no space between the columns. Line graphs generally work in the same way as histograms, except the lines are used to show where the top of each column should reach. So it's sometimes quite useful when you're comparing two distributions, so they can be drawn on the same graph. Scatter graphs show us the relationship between two variables. So it allows us to see the strength of the relationship and the direction of the relationship. Distributions, so we can have a normal distribution, so that's a symmetrical bell curve, and most of the scores are clustered around the mean. We can have a positively skewed distribution, so most of the scores are bunched towards the left, and the tail goes to the right. So for example, if an exam was difficult, most of the pupils would score low, so that's why most of the scores are on the left, and very few would score high marks, so that's why the tail is to the right. Negative skewed is where most of the scores are bunched towards the right and the tail is to the left. So remember, if it's sometimes referred to as left skewed and right skewed, that is to do with which direction the tail is going. So for example, if an exam was easy, most of the pupils would score highly, so that's why most of them are bunched towards the right. And few people would score lowly, so therefore that's why the tail is to the left. So levels of measurement. So you need to be aware of nominal, ordinal and interval data. So nominal is data in categories. So each item can appear in one category. There is no order. So people name their favourite football team or their favourite colour. Generally, the measure essential tendency you will use is mode, the most common. Ordinal data is where the data can be put in an order, but the intervals or the gaps is variable. So the score of 8 might not be twice as much as a score of 4. So we ask people to rank their football teams out of 10. Or we ask people to put their favourite subjects within order. We can use the median or the mode. Ordinal data lacks precision because it's based on subjective opinions rather than an objective measure. Interval data is where the gaps of an equal size. So the intervals are equal. So if I was doing an observational study, I can conclude that 8 tallies is twice as much as 4 tallies. Or any unit of measurement that is public, so time, temperature or length. So the gap between 1 and 2 degrees Celsius is the same as the gap between 20 and 21 degrees Celsius. I can use median, mode and mean for interval data. Generally it's better than ordinal data because it is more detailed and it preserves the scores that are not converted into ranks. So the sign test. The sign test is the only statistical test that you will be asked to carry out. The other ones, you just need to know the criteria of when and why you would use them, and you might be asked to input data within a formula that's given to you, but you won't be asked to calculate it. So why would we carry out the sign test? What is the criteria for the sign test? So our hypothesis says there's going to be a difference. It's a test of difference. It's not a correlation or an association. The data is related, so that means a repeated measures or matched pairs design has been used, and the data is nominal. How do I calculate the sign test? So the scores from condition B is taken away from condition A to produce a sign of difference. So I'm either going to get a positive plus score or a minus score. I add up the number of pluses and the number of minuses, and I accept the S value as the one with the lower number. Any participant who got the same score in both conditions are not counted and they're taken away from the N value, so the number of participants. So as I said, the S value is the total number of the less frequent sign, so it's the lower number you have created. So if I look at this, I wanted to see whether happiness would improve after watching a comedy. So participant 1 scored 6 on the happiness score before watching the comedy and 5 afterwards. So 6 minus 5 is 1. So I get a plus score. 3 minus 4. So I get a minus score, so that's minus 1. 4 minus 6 is minus 2, so I get a minus score. 8 minus 6 is minus 2, so I get a minus score. I carry on like this through all of my data set. If we look at participant 11, they scored 4 in both conditions, so I would give them a 0 score. So if I add up my number of pluses and my number of minuses, my pluses add up to 3. My minuses add up to 10. Therefore, my S value is the lower frequency, the lower number. So I accept that S, or I calculate that S is 3. My number of participants is 13 because originally I had 14 participants, but remember I take away 1 because one of my participants got a value of 0. If I had 2 participants that got a value of 0, it would be 14 minus 2, and I'd end up with an N value of 12. How do I work out whether it's significant or not? So in the scenario, you should be told what level of significance that you need, but generally in psychology we use 0.05. Then you will also be told whether it's a one-tailed test or a two-tailed test. One-tailed test, remember, is a directional hypothesis. Two-tailed test is a non-directional hypothesis. So in this case scenario, we're going to look at a one-tailed test for the level of significance of 0.05. Therefore, I highlight that column. I also highlight the number of participants. So remember we said that our number of participants, our n value was 13. So I highlight the 13 row. Therefore, I get a critical value of 2. So for the sign test, our calculated value needs to be equal to or lower than our critical value for it to be significant. So in this case, it wouldn't be significant. So let's have a look at our numbers again. Our S value is 3, so that's our calculated value because you calculated it. Our critical value is 2. So in order for the test to be a significant result, the calculated value for the sign test needs to be lower or equal to the critical value, which it isn't. So therefore we do not have a significant result.